For this project, we are using some data collected from the webpage of Minitab. The problematic we used was about a juice company who wants to reduce the waste of the pulp from their juice. They consider three factors: factor A, the temperature; factor B, time of production; and factor C, the concentration of the same juice. After the process, they end up with some waste that have to be cleaned from the machines.
The levels used in this experiment for each factor were temperature 120 and 180 degrees, time 10 and 30 seconds, and concentration in percentage of 2 and 6. Following the rule of multiplying the total of levels of each factor to know the minimum number of runs we need for the experiments, we end up to need at least 8 runs. But for this case, we use a total of 16 runs for a better result. For the next box plot, we choose two different things: the most important factor, that is the temperature, and the most important interaction, that is the temperature against the concentration. As we can see, the average when the temperature is 120 is located around 44 of waste with a range of 50 and 61. On the other hand, when the temperature is 180, the average waste is 44 with a range of 35 and 45. While the interaction of temperature and concentration we divide in two. For 120 degrees with concentration of 2% has an average of 56 with a range of 48 and 63. With a temperature of 120 and concentration of 6 has 44 as the average and with range of 50 and 60. For the temperature of 180, first with the 2% of concentration, the average is 43 with range of 39 and 45, and with a concentration of 6, the average is 45 with range of 40 and 60. For knowing from which factor interaction we should do the box plot, it was necessary to use the ANOVA table that let us see which factors of interaction are the most relevant. Using a confidence level of alpha equal to 0.05, we can see that there is a significant difference in the interaction between temperature and concentration, while the temperature is the most relevant factor.
From the 2K as seen in class, it is used to know the best levels of each factor and the combination of factors that will give us the best results. For this case, we are going to explain the most important ones. The 2K of temperature, which is divided in two groups, and because we are looking for a reduction of waste, the group B is chosen with a temperature of 180 degrees. The 2K of the interaction of temperature and concentration percentage, which is again the B group, with the same result as before, 180 degrees, as the perfect temperature and both levels of percentage. For the interval of confidence, it is necessary to use the next formula. Using this formula and the results obtained in our 2K, we can give a confidence interval for the first interaction that the waste is going to be between 37.88 and 46.1 units, while the second one has a waste between 43.88 and 52.11 units. With these results, we can assume that the best combination is the first one of 180 degrees and 2% of concentration.
For getting better results in future projects, it is necessary to know how many variables you will need in each combination of factors to avoid getting an error of second type. That means when the designer of the experiment accepts a new hypothesis that is incorrect. Of course, taking in consideration that it is possible to get those variables. To do this, it is necessary to know the number of tests for each temperature. In this case was 8 tests per temperature, while the total factors were 3. The next table is based on alpha equal to 0.10, meaning that we have a confidence of at least 90% of avoiding the error type 2. After doing this process, we end up with a muestral size of 6 variables to avoid the error, with a confidence level of 91%.
In conclusion, and based on analysis, our proposition consists in using a temperature of 180 degrees with a concentration level of 2%. This is because, according to the analysis, this combination of factors will reduce the pulp waste in the machine and in the final product, the juice.